A body of mass 5 kg is taken from height 5 meter to 10 meter. So 5 meter to 10 meter, the net displacement is 10 minus 5, that is 5. Okay, so this much is displaced vertically. Find the increase in potential energy, and we have to take G as a 10. So how to go about these kind of questions? So potential energy at a height will be mgh. In this case, because there are two distances are given, like 5 meter to 10 meter. So we will subtract the final position minus initial position. So that will be the displacement. Now how to think about it? What will be the increase or decrease in potential energy in any question? So always think about, we need to put a negative sign on work done by gravity. So there will be no confusion, because in some cases it may happen we are putting more force than the gravity is applying. So like for example 100 Newton, right? If I apply 100 Newton, I do the same displacement, the answer will not be the same. So the best technique will be always calculate the work done due to gravity, flip its sign, that will be equal to change in potential energy. So that will be change in potential energy. Delta here, this sign delta means change in potential energy, final energy minus initial potential energy. So that way we can do very easily. So we work done by gravity in this case, we are displacing it by 5 meter. Now we know 10 minus 5 is 5. So we are displacing by this. Let's calculate work done by gravity. And gravity force is acting like this. And that is of 50 Newton, because I have multiplied mg. Mass was 5. I multiplied by g, which is asked to take as to be taken as 10. So that's why it's coming 50. So 50 Newton is the force, and displacement is in another direction, 5 meter. So the work done by gravity will come as a negative. So it will come as negative of negative 50 and 5 to 50. Sorry, 50 into 5 is 125, 125. And now these signs will cancel out and we will get positive value of 125 joules. So this much kinetic energy is changed. It is in increase because delta, this is delta potential energy, has come positive. It will come negative, it means we have decreased the potential energy. So always remember, if you want to calculate the potential energy, we should use this to avoid any confusion in the force. In this case, the question was very simple. They are asked exactly equal. We are assuming that we are, you know, putting the force exactly equal to the 50 Newton, but that is the assumption. So if they ask some other force, the change in potential energy will be always a negative work done by gravity. So that way we can calculate. Let's go next. So this is question number 4 actually, not 2. A block of mass 30 kg is pulled up a slope as shown in figure like this. I am showing it by just a point mass. So this is a point mass. I'm not showing a box so that we understand better where is the displacement and where is the force. With a constant speed by applying a force of 200 Newton, force application is this, parallel to the slope. So it is the parallel to the slope. 200 Newton is this red arrow. A, B are the initial and final position. This is A, this is B. Calculate the work done by the force in moving the block from A to B. So A to B, the work done will be simply FD cos theta, FD cos theta, 200 Newton force, 3 meter displacement because this slope is of 3 meter, A to B, and cos 0 will be 1. So we have done work done of 600 joules. So work done in moving the block from A to B is 600 joules. Now let's see the second part of the question. Second part, they're asking us the potential energy gained by the block. Okay, the potential energy gained by the block. Now in the diagram, they have given us the vertical height. So whenever we are talking about potential energy, we are interested in vertical displacement, not the horizontal. So if we know the how much vertically it got displaced, we can calculate the change in potential energy. Again, we can apply minus change in potential energy is minus work done by gravity. Work done will be negative here. See, the force is the mg will be downwards. So mg will be downwards of to how much it is? 30 kg, right? So 30 into 10, say, so 300 Newton, 300 Newton. So it will be 300 Newton force of gravity downwards. And we have to take consideration of vertical displacement. So it will be 1.5. So that will be minus of, let me calculate the work done by gravity because they are opposite. They are having negative sign. So 300 into 1.5. 300 into 1.5, and they will have a negative sign. This negative sign will cancel, and we'll get the answer as we are doing 450 joule as here. So 450 joules will get the answer. So minus work done by gravity always gives you change in potential energy. So remember that. But one catch is always there, that the height should be taken vertically. So we should be concerned when we are talking about potential energy change. We should take how much vertically it is moving up or down instead of getting into the slopes how it is moving. Okay, let's go. Account for the difference. So the difference is, see, the work done is done 600 joules. We have given that box energy as 600 joules, but the potential energy is only increased 450 joules. So where is that 150 has gone? So that must be gone into the friction force, because see, the kinetic energy has not increased. That's why they have told that we have pulled it with the constant speed. The speed has not changed, so kinetic energy cannot change. Only out of 600 joules, 450 got converted into potential energy, and rest of the 150 joules got dissipated. That is a dissipation or waste of energy, we can say, due to friction, maybe sound, maybe heat. That way this energy has gone. So understand this. So this is the account for the difference. Last part they are asked, the work done on the body 600 joules, out of which 400 joules was used to increase its potential energy. Where it can go, as we are pulling it at constant speed, it is not used in changing kinetic energy, that we are sure of. So rest of it, 150 joule, is wasted or dissipated, maybe in the form of friction, sound, or heat. Let's do this question. Let's do this question. This is question number 2. A body of mass 1 kg falls from a height of 5 meter. How much energy does it possess? How much energy does it possess at any instant? So any instant will be the same energy of mechanical energy here. If it is at height, so we can calculate its potential energy, mg delta h, by mg at delta at h expression, and then we can, that potential energy will be here as mechanical energy, because here the kinetic energy is zero. The kinetic energy is not there, it's zero. So the total mechanical energy is sitting here as potential energy. But as it falls, will mechanical energy change? Because they have said how much energy does it possess, it will possess the same energy, same mechanical energy. This will remain constant because the fall is under gravity, under a conservative force. So the mechanical energy remains constant. So whatever the potential energy, it will of course reduce, but the reduction in potential energy will get converted into kinetic energy. So the sum of potential energy and kinetic energy will be still hold true as constant at any instant. So let's read the theory here, what I have explained. But there will be no kinetic energy at the top. As the body falls, the potential energy gets converted into kinetic energy, but the mechanical energy will be conserved, because we know mechanical energy is potential energy plus kinetic energy. In the question, they have asked about energy, not specifically about potential energy or kinetic energy. That's why at any instant the energy, and that is mechanical energy, will be same. So the energy will be the same as 49 joules, which is, I have calculated like mg delta h. Mg is the m is the mass is given 1 kg. We'll just multiply it by 9.8 and then multiplied by with the height h. So here I have used delta h, don't get confused. We are just assuming h is final minus initial. So we are assuming that, the ground is zero at height zero. So this will be delta h will be 5 meters that way. Okay, let's go ahead. In a dam generating hydroelectric power, water falls at rate of this much, 100 kg is falling per second. from a height of 100 meter. Okay, height is also given. First, calculate the initial potential energy of the water. Okay. B, assuming that 60% of the energy is falling water is converted into electric energy, calculate the power generated. So what is happening is we are getting water at this rate, but not all the energy which is coming is getting converted. That happens because our machines are not perfect. We are not able to take entire energy which is coming down with the water and getting converted into the power generation. So there are some losses. So that is why they are saying 60% only is getting generated. So let's say how we can answer this question. First thing, we have to calculate how much energy is coming, or we can say how much work is being done on water when it is coming down 100 meter. So 100 meters is shown by this blue sign displacement. Let's say here is the machine. So 100-meter depth that is coming down from here. So this will be the height mg delta h. The potential energy we can count here. Mg will be 9,800 because we are taking 9.8 as g as it is specified in the question. So the mg will be 1000 into 9.8 into 100, and we will get the answer like this. So this was the potential energy here, right? This was the potential energy. So that is what is asked. What is the initial potential energy? We just calculated mg delta h, and with that we can calculate what will be the potential energy here at the top. Now this potential energy, as the water will trickle down like this, it will trickle down, it will come here. What will happen, that entire potential energy will get converted into kinetic energy here, right? If we are assuming this is a ground, or where potential energy we are assuming 0, so the entire PE, potential energy, which was here, is got converted and became the kinetic energy here of this much. Now what they are saying is this energy is delivered on per second basis. So the power input is this. It means what power we are getting, right? Because they have already told that the rate is 1000 kg per second. So it is already in the per second format. So we are getting this much energy, 9.8 into 10 to the power 5 watts, or joules per second of energy. Now let's take about the efficiency of our generator. Only 60% of the power out input is getting converted into output, or power we are able to generate. So the power generated will be 0.6, right? That is what the 60% means. 60 into 60 divided by 100, you can think of like that, and then it will come eventually at 0.6. So it will be 0.6 multiplied by this, so we'll get this much of energy as energy output. Not completely, if you see, this was the input, and see how much it has been lost, right? Around 3 point something is lost here, right? And that goes into heat, sound, friction, uh, that kind of energy that has been dissipated. So that's why we are getting lesser power generated. Let's read this question. A truck driver loads some oil drums into a truck by lifting them directly, like it's just pulling them up. Each drum has a mass of 80 kg. The platform of the truck is 0.8 meter above the ground. A. How much force is needed to lift the drum into the truck? So how much work done, actually, how much work done, if we understand how much force is needed, is very simple to calculate, because the let's see, this is the drum I am showing with the point. So how much downward force due to gravity will be there? That will be 800 Newton. We are taking G as 10 is mentioned in question. So 80 into 10 is 800 Newton. Force is downwards this side. So if you want to pick it up and put it at some platform, say that like platform, say, so let's say this is a platform. Want to pick it up and put it here. So we have to apply the same force. This is the limiting case we take, like we need to apply the same force as gravity is applying. So we assume that it is exactly equal to 800 Newton, and this force multiplied by the displacement, that is the height of the platform, that we will multiply, and we will get the answer as the 800 into 0.8 is equal to 640 joules. So this much work is needed to be done if we want to pick one drum to the platform. Now let's see the other parts what they say. So how much force is needed to lift the truck? We have done that. How much energy? That means how much energy means how much work you need to be done. Right? That is what 640 joules we have calculated. C, after the truck is loaded, the driver drives off. List the major energy changes that takes place in moving the truck. Okay, so if he moves, what happens? The drum was like at the platform, we have already increased its potential energy somewhere because it is 0.8 meter risen from the ground. So this is the truck platform. And now when it drives off, it will also achieve kinetic energy. So now the drum has two energies, kinetic energy also. When it was stationary, it was not having a kinetic energy. And also because it is at height of 0.8 meter, it also had potential energy. So that will be the change. When it was not moving, only the potential energy will be there. And then when it starts moving, the kinetic energy comes into play. So after the driver drives off, here the drum gains kinetic energy as it is moving with the truck with same speed. So the total mechanical energy we can say increases. Okay, let's say what about this? The last part is the driver stops the truck at the factory gate. What happens to the kinetic energy of the truck? The kinetic energy has a simple formula of half mv square. If it stops, the v drops to zero, right? So half mv square, the v drops to zero, kinetic energy also becomes zero. So only the potential energy remains. So when truck stops at the gate of the kinetic energy of drum drops to zero, only potential energy remain, which was it is having earlier.